This video is looking at investments or annuities in the Recursion Financial Modelling section of Further Maths, VCE. So firstly, just a quick recap of what an annuity is. So here we have that combination of growth and decay again. So an annuity investment is where compound interest is being earned on the investment, so that's the growth component. But there is a periodic constant payment being withdrawn, and so that's our decay. So if the bank is paying you interest, we can see from that 50,000 we would increase the balance all the way up, but then a regular payment would be withdrawn, and that amount of the payment is greater than the interest that has been added on, and so overall the balance will decrease. And so that means over time, over the life of the investment, it will eventually run out and have a balance of zero. And so in terms of modelling these annuities as recurrence relations, in Further Maths, we are using our values of V0 being our principal. We would write that then as Vn plus 1, so the next value is R times Vn, the current value, minus D. So in this case, R, capital R, is a growth, so we're doing 1 plus the interest rate over the number of compounding periods per year. And D, we're subtracting that because we are decreasing by that value. We're withdrawing. And a reminder that we have no general rule, so we would be using finance solver if we were asked to do more than just a couple of steps of calculation, and we'll look at some examples later in this video. Our first example here, using a recurrence relation, Phil invests $200,000 in an annuity from which he receives a regular monthly payment. The balance of the annuity in dollars after n months, AN, can be modelled by the recurrence relation. So we have A0, 200,000, that's our initial amount that we're investing, and AN plus 1 equals 1.0035 times AN minus 3,700. And so what we're asked here is, what is the monthly payment that Phil is receiving? So quite often, because we want to use general forms of these rules and use finance solver, we are just asked to be able to identify components of, or how we would calculate components of, the recurrence relation. And so here, remember the payment, that's talking about our value of D. And so recognizing from our rule that's given, D is the amount we are subtracting. So his monthly payment is the $3,700. We're now asked in part B to show that the annual percentage compound interest rate for this annuity is 4.2%. So finding that rate. So remember, we utilise the interest rate to form our value of big R. So we're expected to recognise here that we would be using our formula for R, which is given as 1 plus our interest rate per annum over the number of compounding periods in a year over 100. And so we know that that value is equal to 1.0035. So we need to set up that equation, and we're asked to show that the rate is 4.2. We cannot use that value though in our working. We have to pretend we don't have it. So whenever you see a show that question, you pretend you don't know the answer, and you work through the question and hope that if you've done the right thing, you arrive at the same value they've given you as part of the statement there. And so we need to complete this now. So our number of compounding periods, we know that we are getting monthly repayments, okay, which means our interest is also compounding monthly, so 12 times a year, and then all of that over 100. And so we need to probably do more than just simply state that value. So we would want to start to undo some of this question here. And so if we subtract 1 across, 0.0035, we can multiply our 100 across, and then finally multiply 12 across, and we get the rate as 4.2%. In terms of what is actually required in the exam phase, you will need to, at very, very least, show the setup of the equation, and wherever possible, attempt some of this working here to solve that equation. Okay, you want to, but at very, very least is that initial equation setup. This next example is a paper one, a multiple choice question. So Cheryl has invested $175,000 in an annuity. This investment earns interest at a rate of 4.8% per annum, compounding quarterly. Immediately after the interest has been added to the account each quarter, Cheryl withdraws a payment of $3,500. A recurrence relation that can be used to determine the value of Cheryl's investment after n quarters, Vn, is, we've got our options there. So remember, in your recurrence relation here, you're going to have three key components. You're going to have V0, your investment amount. You're going to have R, that you would use your interest rate to calculate, and you're going to have your payment amount, D. And we can see in the options we've given, all of the values of V0 are the same, all of the values of D are the same. So they're not going to help us not knock out incorrect answers or identify the correct answer. So the thing that we need to focus on then is our value of big R. And so again, let's take the information that we have, where R will be 1 plus the rate over the number of compounds per year over 100. So in this case, we've got an interest rate of 4.8%, and we're compounding quarterly, so that's 4 times per year. Divide all of that by 100. So when I pop that in my calculator, I will get 1.012. And so that leaves me with my correct answer being option D. The other thing you might want to start to sort of look at and knock out is remembering that if you are adjusting that rate to compound quarterly, is checking that none of the values, so for instance in E, that hasn't been adjusted. That's an easy way to knock out that option. The other thing as well is the values in A and B are less than 1, so that wouldn't be showing growth in our interest. So that would allow us to go and knock out A, B, and perhaps E, and making sure we're doing a careful calculation to get our final correct answer. Now we look at amortization tables in the context of annuities. So an amortization table will look almost exactly the same in an annuity as it would in a reducing balance loan. So you just need to be really careful that you are thinking it through carefully and that the values make sense. So here we can see we would have a balance of our investment, and at payment 0, that would be the initial amount. We see our payment amount, so this would be our value of D that's being withdrawn each time period. And we have a column for the interest earned, because we are earning interest on our investment, but then we are also having a balance reduction. And much like previously, the interest earned and the balance reduction, they will add together to give us our payment amount. So we are able to fill gaps or find missing values by just filling a gap, but we also need to understand how to actually calculate each of those individual values as well, if needed. So looking at an example here, we have Harvey has an annuity. The interest is calculated quarterly, and Harvey receives a quarterly payment of $10,000. The interest is charged at 9% per annum. So firstly, we want to calculate the interest charged with payment 1. And you can see we have a little formula up here, a reminder of how we calculate that interest. And so in this case, we take our previous balance of $50,000 and we multiply that by our rate, so 9%, over compounding periods of 4 and over 100, and that will give us a value of 1,125. So the interest earned at that point is $1,125. It should be earned, not charged. The next value to calculate is principal reduction. So we can see here the principal reduction will equals a payment minus the interest that has been earned. So in this case, if we're to calculate the principal reduction for Harvey associated with payment 1, what we would be doing is the 10,000 of the payment minus the interest that has been earned, 1,125, and that will give us a balance reduction of 8,875. And so we would have 8875 there. And the final step, the final value to figure out, is the balance of our investment. Again, the balance of our investment will always be our previous balance minus that principal reduction. So in this case for Harvey, the balance associated after payment 1 will be our previous balance of $50,000 minus the reduction at 8,875. And so that will mean he will have $41,125 in the account at that point. We're far more likely to see annuities being used with our finance solver because of the nature of these style of things. And so we're going to go through three examples now, looking at how we would use finance solver. May invests an annuity that earns interest at a rate of 5.2% per annum, compounding monthly. The monthly repayments are received from the annuity. The balance of the annuity will be $130,784.93 after 5 years. The balance of the annuity will be $66,992.27 after 10 years. The monthly payment that May receives is closest to. So remember, with our finance solver, we are wanting to put in as much information as we can, and so we will always have one thing that we're left to solve for. And so in this case, the other key thing to remember is that we generally think of our PV being our principal value, but it is just any start point. So in this case, we don't know how much she invested to begin with, but we know the first value we are given is that 5-year balance. So we can say that my principal value, or my starting point, will be the 130,784.93. After 10 years, so 5 years later, we will have our future value of the $66,992.27. And in between that time, we have had 5 years pass, and we are making monthly payments. So let's put all of that together into what we can put in our finance solver. So we said 5 years of monthly payments. So 5 times 12, so we'd have N is 60. Our interest rate of 5.2. Our PV, so our starting point, as 130,000, and we are putting that money into the bank. So we're going to put that as a negative 130,784.93. We're being asked to find the payment amount, so that's what we'll come back and solve for. My future value will be a positive because I would get that money back if I close the account at that point. And I'm making monthly payments, monthly compounding periods. Okay, so I've transferred all of that information into my calculator, and when I solve for the payment amount, I can see that May is getting a payment of $1,500 a month. And so coming back here, I see that C is my closest answer. This second example is an example of an exam 2, so an extended response type question. A record producer gave the band $50,000 to write and record an album of songs. This $50,000 was invested in an annuity and provides a monthly payment to the band. The annuity pays interest at a rate of 3.12% per annum, compounding monthly. After 6 months of writing and recording, the band has $32,667.68 remaining in the annuity. What is the value in dollars of the monthly payment to the band? So we're being asked to find what is our PMT value. So here we can see we have our starting value or a principal value of $50,000. We're making monthly payments. Okay, so PPY and CPY is monthly. We've got an interest rate of 3.12 and we have a future value after 6 months of payments. So let's put all of that information into our calculator and then we're going to solve for our monthly payment. Okay, so as we said, we had 6 months of repayments, interest rate of 3.12%. We invested, so negative $50,000. We'll come back and solve for the payment. And the future value, they had $32,667.68. So coming back to solve for PMT, we can see the band is getting a payment of $3,000 per month. And so then just making sure you state your final answer to the nearest cent. I also encourage you to make sure you do write down the values that you've put in your calculator, and VCA would be expecting you to do that as well. So this is a continuation of that question. After 6 months of writing and recording, the band decides that it needs more time to finish the album. To extend the time that the annuity will last, the bank will work for 3 more months without the band will work for 3 more months without withdrawing a payment. After this, the band will receive monthly payments of $3,800 for as long as possible. The annuity will end with one final monthly payment that will be smaller than the others. That's something to note when we find out the time. Calculate the total number of months that this annuity will last. So we need to consider what has happened before we start looking at how much longer the annuity will work for. So we already had 6 months with the previous Part A of payments at $3,000. Then we had 3 months. The band will work for 3 months with no payment, so the balance will remain stable. So we can add 3 more months there. So now we need to add on how much longer this will last if they're making also withdrawing payments of $3,800. So we're going to solve for N. We will have our interest rate is staying the same at 3.12%. My starting point this time though is where I finished at the end of that first 6 months. So that's the $32,667.68. And we are investing that, so I'll make that a negative value. We're going to have payments of $3,800. And if we want to know how long this is lasting for, we're finding out when will our future value be 0. And our compounds and payments are still happening monthly, so 12 times a year. So I've transferred that information into the finance solver, and now when I solve for N, I get N is 8.7. And so that little piece of information about the final payment being slightly smaller than the rest mean here I'm going to get 8 full payments of $3,800 and then 1 final payment of a little bit less. So I can tell that by 8 full payments plus a little bit more, and that wouldn't matter what that decimal place was, as long as it was, we're talking about being above that value of 8. So when that means when I come back here, I'm actually going to add on 9 more months to the band's payments, or the longevity of that. So I've got 6 plus 3 plus 9, therefore I've got 18 months in total that the annuity will last. So being careful here that you need to consider that initial period that was part of Part A, the 3 months where there were no payments being withdrawn, and then adding on what length of time the annuity will last for after we've changed the conditions. Okay, that's it for this video. Hopefully that was helpful in terms of annuities and finance.